You've learned a little bit about z-scores. I'd like you to please pause this video and attempt to answer this warm-up question. Okay. The first one says that the mean of a set of values is 5, so the mean is 5. The variance is 4, and the mode is 3.5. What is the score of 8 expressed as a z-score? Now I know a z-score is going to be x minus the mean. I can either write x bar or mu. Let's write mu. Over the standard deviation, let's write sigma. So the x is what I want to find the z-score of. That's 8. Minus the mean is 5 over, I'm not given the standard deviation. So what am I supposed to do? Do I quit and go home? Hopefully some of you remember that variance is the same thing as the standard deviation squared. So if the variance is 4, then the standard deviation is 2. So now I have 8 minus 5 over 2, which is 3 over 2, or 1.5, and the answer is B. Second question, Sarah and Jerry took a math exam. Sarah's percentile score on the exam was 40. Jerry's percentile score on the same test was 80. We know that Jerry correctly answered more items than Sarah. Sarah correctly answered half as many items as Jerry. They both scored better than the median, and Sarah scored better than 40 of her classmates. Let's see which of these could be true. So Sarah's percentile on the exam was a 40, which means Sarah got higher or the same as 40% of peers. Whereas Jerry's percentile was 80, okay? And so he did higher or the same as 80% of his peers. All right, so does that mean that Jerry correctly answered more items than Sarah? Yes, it does mean that. A is true. B, Sarah correctly answered half as many items as Jerry. I don't know why I changed the spelling of Jerry's name here. Sorry about that. No, B is not necessarily true. It could be true, but the fact that her percentile is half of Jerry's does not mean that she answered half as many items. Her score could have honestly been almost the same as Jerry's if there were a whole bunch of people still between them with a score in between those two. This actually tells us nothing about what their actual scores were. It tells us where they stand relative to their peers. C, they both scored better than the median on the math exam. No, this is not true. What percentile is the median? The median is the 50th percentile. Okay, so although I would say Jerry did better than the median, Sarah did not. She actually was below the median. D, Sarah scored better than 40 of her classmates. This could be true, but is not necessarily true. This would only be true, I guess, if she has 100 classmates. So if she did better than 40 of them out of 100, that would be the 40th percentile. But we don't know how many classmates she has, so we don't know for sure that's true. So I would say A is definitely true. B could be true, but is not necessarily true. C cannot be true because the median is the 50th percentile. And D could be true, but only if she has 100 classmates. The only one we know for sure is true is A. All right, this second video of the day, I don't have any new content to show you. I just want to answer some questions that are commonly asked about z-scores. The video that you just watched was one that I usually assign for homework, and so I want to bring up some questions that are often asked in class following that video. So first question, what happens when the z-score is negative? What does that mean? I think the video actually addresses that, but a negative z-score just means that you're below the mean. Okay, so a z-score of -2 means I am 2 standard deviations less than the mean whatever. Second question, will we always be given the mean and standard deviation when calculating z-scores? What if they don't give you a standard deviation? Yes, if you're being asked to calculate a z-score, you'll be given a mean and standard deviation. The only exception to that is like in the warm-up problem where I gave you variance instead of standard deviation. But generally speaking, yes, you will be given the mean and standard deviation or enough to get the mean and standard deviation. For example, I could give you the actual data. You could put the data in the calculator, use the calculator to find the mean and standard deviation, and then calculate the z-score. However, it's much more common to be given both. Will z-scores also apply to other graphs that aren't normally distributed? This is a great question. Yes, z-scores make sense for things that aren't normally distributed, but there are things that you can do with z-scores, which we're going to learn on Wednesday and Thursday, that only make sense on a normal distribution. So z-scores apply to any distribution. It's just that they're more powerful, let's say, if they come from a normal distribution. Could z-scores still be applied if you had a mean of 0? Absolutely. Mean of 0, no problem. It just makes it really easy to subtract the mean. How will we know when to solve for a z-score in a problem? For now, it's going to say find and interpret the z-score. Okay, it will ask you to do that. Later on, z-scores are just going to be one step in a multi-step process, and you'll need to know that that's one of the steps. But for now, they'll tell you. Next question is interesting. I don't understand why the higher z-score is better. So I think this is in reference to the problem about, I think it was about batting averages. A higher z-score meant that you were more standard deviations above the mean. More standard deviations above the mean. Which if we're talking about batting averages, having a higher batting average is something that you want. So being further up along the curve, let's say it is normally distributed, if we're talking batting averages, you'd much rather be here than here. And you really don't want to be over here with a negative z-score. That means you're below average. All right, but that's not always the case. My answer to this question is a higher z-score is not always better. If we're talking about blood pressure, then having a really high z-score means that your blood pressure is several standard deviations above the mean. Do you want much higher than average blood pressure? I don't think so. Okay, so a higher z-score is going to be better when a bigger number is better, but if a bigger number isn't better, then a high z-score is not going to be desirable. For 68, 95, 99.7, is there a rule for z-scores that fit between 1, 2, and 3? Okay, for example, if my z-score is 1.5, if I'm 1.5 standard deviations above the mean, how can I find percentages associated with that? This is a great question. My answer to that is Wednesday. Wednesday, we're going to learn how to do that. Okay, so just keep that in mind. It's really interesting. It's kind of a fun type of problem to solve, and we're going to learn how to do that on Wednesday. When we figure out the z-score for a question that includes units, do we include units in our answer? Great question. Answer is no. Z-scores are unitless. Z-scores do not have units. They are a standardized measure. Your z-score of your height in centimeters and your z-score of your height in inches are going to be the same because the mean is going to be converted from centimeters to inches, the standard deviation is going to be converted from centimeters to inches, and the units end up canceling out. Let's say out of 100 students I got the lowest score. Would saying that I'm in the negative 99th percentile be the same as saying that I'm in the first percentile? Is that possible? No. Percentiles cannot be negative. If you got the lowest score, then out of 100 students, yes, you would be at the first percentile. You got the same or lower than 1 out of 100 people, assuming nobody else got your same score. So that would be the first percentile. We cannot do this subtraction thing and call it the negative 99th percentile. That does not make sense. Don't do it. For the AP exam, is it just going to ask a question, or will it say what is the z-score of ... You know, this is not going to be a question on the AP exam. This is going to be one step of a much larger problem on the AP exam. So don't worry about that just yet. For means, we have the Greek letter mu, and we also have x bar. Same thing for standard deviation. We have the Greek letter sigma, and we have the S, okay? Both are used for different things. Don't worry about why. We got a little further when we asked this question. The question is, does z-score have two symbols as well? Do I have a Greek letter for a z-score? Fortunately for you, the answer is no. It's just z. Don't worry about adding a Greek letter in there. We're going to do enough of that later. So I know that the videos for today didn't take up the entire period, so I'd really like you to spend the remainder of class time beginning this homework assignment. Again, we're in Chapter 2, so this is problem 2.1, 2.3, etc. And I want to remind you that you have a quiz tomorrow. The quiz tomorrow is going to cover all of section 2.1. It's going to involve density curves, which we learned about on Friday, as well as z-scores, which you learned about today.